4.9 antiderivatives. Here we go. We're starting to get prepped for Calc 2. Let's do those, integration. You ever heard of that? Well, integration and antiderivative is very close, very similar. A little different, but similar. We find antiderivatives to solve integrals. But what's cool about an antiderivative, it's just what it sounds like. You know how to find a derivative, now go the other freaking direction. That's going to be our game. Oops. All right, we got a couple definitions. Actually, we got a definition. We have a theorem, and that's it. So we're not going to stress out too much about anything it says. We're going to wait and see before we stress out. And we go, a function f, this big F. Let's zoom in so we can actually see it. Big F is called the antiderivative of little f. If when you take the derivative of the big one, you get the little one. Don't stress that we're going to see this weird shit. It's not that big of a deal. We're just saying big F is the opposite of a derivative. So if you were to take a derivative on big F, you're going to get little f. It's going the other direction. For all x in some sort of interval, just saying in some little place, it's going to work for all of our x. All right. It just means the domain's there. Don't trip about that piece. And then here we go. Here we go. If f is an antiderivative of little f on an interval I, don't stress about the interval I. That's what the domain is, what we're talking about. Then the most general antiderivative, not the antiderivative, but the most general antiderivative of f on that interval I is big F of x plus c, where c is some arbitrary constant. See what I mean? Let's just check something out. Well, like, all right, well, f of x is equal to, I don't know, maybe we do something like this. 3x squared. Cool, now we want to try and find an antiderivative. Can you see something that might have a derivative of 3x squared? Can you see it without me giving you the formula? We can call it some big F of x. Well, what has a derivative that equals 3x squared? And I think that's going to be x cubed. Doesn't x cubed have a derivative of 3x squared? It does, but you know what else does? X cubed plus 4. That also has a derivative of 3x squared. Do you know what else does? X cubed minus 17,021. It's like, shit, we don't know. If it's a number, doesn't it just typically go away? And that's why we write plus c. This little plus c. So when we're finding an antiderivative, a general antiderivative, we just write in the antiderivative plus c. Because we don't know what the hell it's going to be. And you know what c plus c equals now? C. We don't give a shit what it is. There's no sign. We don't care about what it says. Plus, you can write x cubed minus c if you want to. We're just saying there's some sort of constant that could be hanging out at the end. Let's go. And then we got a table of some antiderivatives. And they might look a little bit scary, but it's no big deal. We're going to be able to handle them. Let's not look at these first ones. This one's a little rough. I'll break the other ones down a little simpler for you. So let's move from right to left. What's the derivative of ln of x? It's 1 over x, right? So we say when we go the opposite direction, when you take the antiderivative of 1 over x, we're going to get the natural log of the absolute value of x. I talked to you about it in class, and I told you derivatives, we don't give a shit about it. We don't need that absolute value on the ln. But when we antiderive, you have to have that absolute value. All of us math teachers will smash you for not having the absolute value. So we got to be careful with it, okay? What's the antiderivative of e to the x? Oh, what's the derivative of e to the... No, that's not too bad. That's not too bad, right? So we're going through the list. The derivative of sine is cosine, so the antiderivative of cosine is sine. The antiderivative of sine is actually negative cosine. Why is that? Because the derivative of cosine is negative sine, and then we're just changing the sign. Thanks. So as we go through, you can see that it's all the things that you should already have down. In 4.9, we're only going to use this and algebra. It's not until you get into like 5.3, 5.4, 5.5 that we start to get crazy. This is all you need to know for right now as we trudge forward towards integration. So we have our different rules. Now look at this. You're going to have to be able to recognize something like that. Or something like this is the antiderivative being sine inverse. It's antiderivative being tangent inverse. So now we have to be ready for new patterns. All this is in your text. Let's keep going. Let's just talk about a power rule for antiderivatives. That's what was written back over here, right? Something similar to this. Yeah, same thing. We got the same stuff. I just wrote it down. We got a function. We can't have that n equal 1, okay? N can't be 1. It's not going to work quite like this, okay? This isn't how we're going to do it, because what's 1 minus 1 is all bad. It's all bad. X can't be 1. N can't be 1. So let's see some examples right next to this. Let's say we have some f of x, and it's equal to, let's just call it x to the 7th. And we want to find its general antiderivative. So there it is. All right, this big F. Soon you're not going to have to deal with this big F, small f bullshit. We'll have a little symbol. It's a little sumo looking thing. All right, so we go. All right, our rule. So it says we have x to the n. So our n is 7. So here's how the game works. This is how I think about it. It's the opposite. It's the opposite of a derivative. So wouldn't you first let your exponent fall and then you'd subtract 1? Now it's the opposite directions. It's the opposite directions. We're going to add 1 to our exponent first. So we're going to say we got x to the 8th. We add 1 to our exponent. And then we look at whatever the exponent is, and that's what we divide by. And then we write plus c, or we get our hand slapped. You've got to get those plus c's. See it again? Let's say we have some g of x. And that's equal to, let's go 3x squared. So our big G of x is equal to, now the 3 is going to go along for the ride. That doesn't go anywhere, okay? That's a constant, or that's a coefficient. So let's play that game. We're going to add 1 to our exponent, right? We're just going to add 1 to our exponent. So we're not going to say it's x squared. We're going to say it's x cubed. Add 1, and now divide by that number. Well, holy shit, those 3's just cancel out and leave us with x cubed plus c, because the derivative of x cubed is 3x squared, and we remember to put in our plus c. All right, so there's just a couple quick ones for you, just to get you started. This stuff is not that bad. I know it looks a little weird, but come on, y'all. We got this shit. We can do it. So next time we come in, we'll have some more antiderivatives. There's not going to be a lot of lectures on this, because you already kind of got it. So we'll have 4, 6, or 7, or 8 of them next time. We'll see you soon.